Euclid did not simply take pictures of galaxies. It revealed the invisible structure that controls them. At first glance, the images appear breathtaking. Thousands of glowing galaxies, brilliant clusters, and deep fields filled with light. But the longer you study them, the more unsettling they become. The galaxies are not scattered randomly across space. They are arranged into vast lines, gathered into dense knots, and separated by enormous empty regions. The force shaping all of it is something we cannot see: dark matter. Euclid has shown that the universe is not a peaceful ocean of stars, but a hidden machine whose invisible framework governs everything we observe. This discovery matters because Euclid was built to map the dark universe, not just the objects that shine, but the unseen forces that control what shines. Its images allow scientists to measure tiny distortions in the shapes of distant galaxies caused by invisible mass bending space and warping the light traveling through it. In other words, Euclid is not merely photographing the universe, it is revealing its skeleton. And if these very first images already display structures this vast, this organized, and this dependent on forces we still do not fully understand, then an unsettling question naturally follows: what will the complete map reveal? Euclid is unlike the telescopes most people are familiar with. It was not designed to capture breathtaking close-ups of colorful nebulae, nor was it built to focus on a single galaxy until every detail becomes crystal clear. Instead, it was created for something far more ambitious and far stranger. Its mission is to map the invisible universe. At first, that sounds impossible. How do you photograph something that emits no light, reflects no light, and cannot be detected directly by ordinary instruments? The answer is surprisingly elegant. You observe what it does to everything around it. That is Euclid's true strength. It doesn't simply observe galaxies. It measures the subtle ways they are bent, stretched, grouped together, pulled into enormous patterns, and separated by vast cosmic voids. Galaxies are not drifting randomly through space. They follow an invisible framework, a cosmic skeleton made primarily of something we still do not fully understand: dark matter. This is where the images become truly unsettling. At first, they seem peaceful. Tiny galaxies sparkle like grains of glowing dust. Clusters hang silently in the darkness. Spiral arms, faint smudges, and ancient points of light tell stories that began billions of years ago. Yet beneath that beauty lies an extraordinary hidden order. Those galaxies are not choosing where to exist. They are being guided, drawn into gigantic filaments stretching across distances so immense that the human mind struggles to comprehend them. These filaments gather into enormous nodes where galaxy clusters form, while leaving behind vast cosmic voids where almost nothing exists. The invisible force creating this architecture is not a minor detail of the universe. It is its dominant structural framework. That is what makes Euclid fundamentally different from other observatories. The James Webb Space Telescope reveals incredibly detailed views of specific cosmic targets. Hubble gave humanity some of the most iconic images in the history of astronomy. But Euclid is attempting something colder, broader, and far more statistical. It is constructing a map so immense that individual galaxies become nothing more than data points in a structure larger than imagination. A map of space, a map of cosmic history, and a map of gravity's invisible fingerprints. That is why these images are far more than beautiful photographs. They are evidence. Every faint galaxy is more than a galaxy. It is a marker. Every tiny distortion in its shape is more than an optical effect. It is a clue. Every galaxy cluster is more than a collection of stars. It is a knot within an enormous cosmic web that cannot be seen directly. And Euclid is beginning to trace that invisible web. The unsettling truth is that scientists already knew dark matter had to exist. Galaxies rotate too quickly for their visible matter alone to hold them together. Galaxy clusters remain bound by far more gravity than we can account for. Light bends around massive objects that simply cannot be seen. For decades, mathematics has pointed toward an invisible universe. But there is a profound difference between knowing that a hidden force exists and actually seeing its shadow stretching across the entire cosmos. That is exactly what Euclid is doing. It is revealing that shadow, not in one galaxy or one cluster, but across the cosmic landscape itself. As more of the map is completed, it becomes increasingly difficult to imagine the universe as empty space dotted with isolated islands of stars. The galaxies are not isolated islands. They are lights attached to an invisible framework. The true structure lies beneath them, massive, unseen, and older than the stars themselves. This raises one of the most profound questions in modern astronomy. If most of the universe is shaped by something we cannot directly observe, then how much of reality have we misunderstood simply because we have spent centuries looking only at the light? That question becomes even more unsettling when Euclid released its first enormous cosmic mosaic. The initial section of the map was anything but small. It was immense, yet still represented only a tiny fraction of the final survey. When the first major mosaic was unveiled, its scale was almost beyond comprehension. It was not a single photograph in the ordinary sense. Instead, it was assembled from hundreds of separate observations, stitched together into one enormous view of the sky. Within that single mosaic were millions of objects, stars from our own Milky Way, galaxies scattered far beyond it, massive clusters, faint smears of distant systems, and ancient points of light whose journeys toward Earth began billions of years ago. Yet perhaps the most astonishing fact is this: that enormous mosaic represents only a tiny fraction of what Euclid is ultimately designed to create. It is not the final map. It is not even close. It is merely a preview. The first page of a much larger story. A warning of what is still to come. Euclid is designed to survey more than 1/3 of the entire sky and produce the most detailed three-dimensional map of the universe ever attempted. That means the breathtaking image we see today is not the conclusion.